Alright, first things first. I am recording this this little segment after I've recorded the whole video, so this is in hindsight. The video that you're going to be watching is covering, or will cover, or has covered classes. Now I have a couple of misgivings about this video, and I would like to share them with you very briefly. First of all, I think that this introduction might have been a little complicated, and some of you might have difficulty following it and understanding what the hell I'm doing. Now, you got to keep in mind, you don't have to expect to master everything in this video by watching it just once. And you don't need to, because we're going to be using this shit over and over and over again. So you will get it. But that being said, if you have absolutely no clue, then this video really wasn't very good now, was it? And in that case, I need to know so I can redo the video. So what I'm going to do is I'm going to make what do you call it? A poll. That's what you call those things. I'm going to make a poll on the forum. And the options for the poll are going to be something like, the video was, I understood enough about it, or I understood everything about it, or I was completely lost. And if most people were completely lost, then I'm going to redo the video. Now, one thing that I would like you guys to know is that if you were fine with the video, you should still answer the poll, because if only the people who were lost answer the poll, then I'm going to redo the video even if the majority were fine. If only the answerers to the poll were lost, then it's going to look to me as if most people had no idea. And in that case, that's going to slow down the schedule for tutorials. So if you thought the video was okay, respond anyways to the poll, because otherwise I won't get a good idea of what you guys all think about it. Other thing is that some of you guys might be a little, I don't know, a little pissed off because there's nothing flashy in this tutorial. You're not going to learn how to make lasers and 3D, I don't know, nipples that shoot lasers and shit and all that flashy stuff. It's going to be basically remaking the scoreboard that we did before, but using classes. So yeah, it's not anything new in terms of a game mechanic, and it's not incredibly exciting, but it is a problem that we've already solved, so we're already familiar with the problem, and that will make it easier for teaching classes. And it's a problem that is very well suited to making a class, and that's why I chose it. It's a very good example problem to solve. That being said, some people are going to be like, I want lasers, and well, fuck it, man. We'll get lasers later. But right now you need to learn how to use classes, so I'm not too worried about that. If you want to bitch and complain about that, just don't, because I'm not interested. But if you were genuinely lost about just how classes work, you had no clue after watching this, because it is a little complicated, I'll admit. I introduced some other things besides classes, some other concepts together. So if you were completely lost, then let me know on the forum in the poll, and I've got an idea for an easier, more gentle way of introducing classes, and I'll probably do that. But if you guys are fine with it, then we can move on and get, closer and closer to whatever you want to learn about quicker. And yes. So that's the thing, and let's get to the video now. Hey guys, it's Chili here, and welcome to my brand new series, the Intermediate Game Programming series. Now, I'm not going to give a detailed introduction to this series in the video. Mainly because most of you guys who are watching this are probably coming from the beginner series, and this is just a continuation of that. For those of you who do not know what's going on, I am going to be making, I've not made it yet, but eventually I'm going to make a a kind of introduction video which, I don't know, explains the whole flow of the series, and I'll put a link to that somewhere here eventually, but not yet. Just very quickly, in the beginner series, I taught you guys the basics of C programming and some of the basics of graphics and shit like that. And in the intermediate series, we're going to move on to the plus part of C++, the object-oriented shit. So we're going to be learning about classes, and that entails inheritance and polymorphism and dynamic binding, all that happy shit. So we're going to be doing that, and in the intermediate, we're finally going to, I'm going to start explaining the nuts and bolts of the framework. So the DirectX SDK stuff and the Win32 stuff. And of course, we're going to be learning more about graphics and the math behind that shit. We might even, we probably will get started on 3D graphics in this series. So that's just some shit to look forward to. But for our short-term goal, my short-term goal for this series in the first few lessons is going to be the framework. So I want to teach you guys the stuff that you need to know so that I'll be able to explain the framework to you. There's not much left to learn. We've learned mostly everything in the beginner series, but there are a few topics that remain. Those topics are the fundamentals of classes. So you're going to need to know just the basics of how to write a simple class. I don't use too much advanced stuff in terms of classes in the framework, so we won't have to learn too much shit. And we're going to need to learn the binary number system. For those of you who don't already know it, you need to know binary numbers, and together with that, bitwise operators, because that stuff comes up in the framework and in Win32 and stuff like that. And just a bunch of other miscellaneous shit. So what I'm going to be doing is I'm going to be covering these topics, and once I've covered them, then I'll go over and I'll explain the entire framework. I'll take a lot of time to explain the background of how Windows 32 and how Direct 3D works, and then I'll give you an overview of the framework, and then we'll probably go and just code the entire thing from scratch. We'll start from nothing, and I'll code the whole thing, and that will ensure that you guys understand every piece of it, as long as you pay attention and shit. So that's the plan. Now, today we are going to learn how to write a class. What I want you guys to do is you're going to have to download the download for this lesson. It'll be in the same place as usual on the forum, and it's basically just the pooface EX plus alpha that we used in whatever lesson that was, in the lesson where we learned about file access. So in that lesson, we added saving and loading, and we added scores to the game, and that is going to be the starting point for this lesson. So we're going to take this system of scores, high score system, and we are going to turn it into a class. We're going to use object-oriented principles to solve this problem of the scoreboard. And we're also going to use a new type of data structure that I haven't taught you guys yet. I wanted to teach you guys during that video, but we weren't far enough, so I had to let it slide. But now we can do it. It's called linked list, by the way. So, but we'll get into that later. The basic concept is we're going to have a class, and we'll call it scoreboard. And this class is going to keep track of individual score objects. So we're going to have another class. Fuck. Wait. Let me get rid of that. Make it a little bigger. We'll have another class here called score. And scoreboard will contain a number of score objects, one for each entry in the scoreboard, right? This is also score, right? And score will contain, obviously, the score and the time. We could also put a name field in here, but I don't want to do text entry on the keyboard and shit like that. We'll save that for another day. So we'll just have the same system as we had before, where the things that are saved is the score itself and the time at which the score was attained. Now, one of the big differences between what we're doing here and what we did before was before we just had an array here, and inside the array, let me just put here, inside the array we had a number of score structures, right? And each structure here had score and the time, score and time, right? And so on and so on and so on. And that array was of a fixed size. I think it only had maybe 10 elements altogether, right? Now, that's fine, but it's not the best solution. In the case where we have less than 10 scores, we have wasted space. And in the case where we have more than 10 scores, we have to eliminate a score from the scoreboard. It's not a big deal, but in this case, but in other applications, this kind of static array would definitely not be the optimum arrangement. So what other things can we do? Well, you might think we could use something like malloc to dynamically create the array. So when we only had 3 scores, we could just use malloc to create an array of 3 score objects here, and that would be fine. But what happens when we have to add a new score to this system here, this array? Well, obviously another one won't fit. So what you'll have to do is you'll have to call malloc again with 4. Damn it! My tablet won't go any farther to the right. That sucks. 1 second. You'll have to call malloc with 4 times size of, and then score. I can't fit it all in there. Bugger. Oh well, you get the idea. So you'd have to do that, create a new array which has 4 entries, then copy these ones into here, and then add the new entry into here. And that's a lot of work. If every time you create if you add a new element to the array, if you have to create a new array and then copy the shit over from the old array to the new array and then delete the old array, that's a lot of work, and it's not the optimum solution. There's other ways of doing it. For example, let's say we have this situation. Wait, let's go back. Back. Keep going. Let's say we have the situation where we have a full array, and now we want to add. We want to add a new element. Well, what we could do is we could malloc an array, this time of size 1, 2, 3, 4, 5, 6. Yeah, we'll say 6. Then we can copy here. We copy these ones here into here, and then we add the new one in here, but we still have some extra space. So the next time we add, we don't have to recopy. So whenever we grow our array, we grow it bigger than we actually need, and that way we don't have to grow every single time we add a new element. We only have to grow periodically. That's another solution, and it's better. It has the disadvantage of having some empty, wasted space, but it's not a big deal. And this situation here is actually called a vector. So if you're periodically growing your array larger than what you need, you basically have a vector. And that's one solution to the problem. But there is another solution that is even more elegant in many respects. And that is what we call the linked list. So what we have for a linked list is we have an element. Let's say we have our score element here. It has score, it has time, and it also has an element called next. And what next is a what am I doing? It's a pointer to a score. So our score object has a pointer to a score. And what you do there is you make this point to the next score in your list. And then this score will point to another score. And this score will point to another score. And the very final score, its next will point to null, meaning there's nothing left. That's the end of the list, right? So in our scoreboard object, we have a single pointer. We'll call it P first, and it points to the first object in the list. And then this one points to this one points to this one, here, here, here. And this is very nice for a number of reasons. First of all, we never have to worry about regrowing an array and copying, because there is no array. These are all just objects that have been created in memory via malloc or via something else that I'll be teaching you very soon. So no array, no copying and growing, no problem there. And the other really nice thing about this is let's say you have the list here, but the list it has to be in order. It has to be a sorted list. In that case, if you had an array, you would have to insert the object into here. You have to copy these ones all down. Remember, we did that in the previous tutorial. Whenever we inserted a new score into our array, we had to copy all the other ones down and then insert it. But in here, if we want to insert an element, we just say, okay, let's say we want to insert this score. We find wherever it goes. Let's say it goes after this one and before this one. Yeah. What we do is we make this one, we just say, okay, you point here now, and you point here, and that's it. Our item is inserted. It's not a big deal if you only have 10 elements. But imagine you have an array of 1,000,000 elements, which is it's definitely not outlandish. It could totally happen in a program. You've got an array of 1,000,000 elements, and you want to insert something at the beginning of the list. That means you've got to copy 1,000,000 things if you want to do that insert in an array. But if you've got a linked list, you just plug it in and you're done. So that's the beauty of linked lists. Now the downside of linked lists is you have a little bit of overhead because every element has to contain a pointer. So that pointer adds a little overhead to your entries in your list, your elements. That's one. And the other downside, the real downside, is that if you have an array or a vector, you can access any element. You want to access the 100th element, you just say I want the 100th element and you got it. But if you have a linked list, there is no way to get directly to the 100th element. If you want to get to the 100th element, you have to start here and then you have to walk the list. You have to access this score, get its next, then access this one, get its next, access, and keep walking the list until you get to element number 100. So an array is random access. You can access any element instantaneously. But with a linked list, you have to access them one after another. So in situations where you have to access things by an index, you generally want to use an array. But in situations where you're accessing them just in order, like in a loop, just going from the first element to the last element, you could use a linked list and sometimes get a big performance boost. So I'm going to be teaching you linked lists by using them in our scoreboard object. Now it's not going to be exactly like this. Actually, let me show you exactly how it's going to be. Get rid of that. Okay, let me think. Oh no, I'm gonna have to be thinking now. I'm not used to that. Actually, that is exactly what it's gonna be like. Never mind. I just erased all that shit for nothing. Because this is what we're gonna have. We're gonna have a scoreboard object or scoreboard class. See, I gotta fucking make a distinction now because I've been kind of using these terms interchangeably. But a class and an object are different. A class is like it's like a cookie cutter. You know those cookie cutters that you use to make, I don't know, those like sugar cookies or whatever. You put them in a baking sheet and you roll out the dough and then you whip out your cookie cutter and you go bam, bam, bam and you make a bunch of star shapes or whatever you fucking want, right? Classes are the cookie cutters. They tell us the shape of the objects that we make. Objects are instances of the class. So we take a class and we create objects that are based on that class. So we have a class that would say score, but these objects would be like score 1, score 2, score 3, so forth, right? It's like int is a data type, and we can create variables of the type int, like I don't know, x, y, whatever. And classes are just another data type. They define what the objects that are created, what their attributes are, what kind of data they include, what kind of operations they have. Alright, so that's the difference between class and object. Class is the cookie cutter, and object is what you get when you take the cookie cutter and you jam it into some dough. That's the distinction. So now let's open up our thing here, our project, PooFace EX plus alpha, right? And let's take a look at our files here, game.h. So right now we have this high score structure. This is going down. You're going down structure. And here in game we have a bunch of functions for managing our scores, for maintaining them. Save the scoreboard, get the score, load a score, and so forth. So we're going to be replacing this shit with a class. Alright, so let's just jump right into it. I mean, I was going to fucking explain classes. I'm going to start in I'm going to comment this shit just to be safe. I was going to explain classes in like console mode and taking it really easy with a simple academic example. Something very abstract and easy to understand. But I figured, fuck it, we'll just jump right into it and, let the chips fall where they may. So, let's make a class here. And we're going to call it scoreboard. you always name your classes things. Like they should be a thing. It shouldn't be like I don't know, like manage scoreboard or something like that, like an action. It should not be an action. It should be a thing, like a scoreboard or a hunk of poo or something. The one I was gonna do for like a simple example was gonna be an emo, but I figured I shouldn't do that. It might offend some people. One of the methods is gonna be like cut myself, but no, we won't do that. We'll take the high road. Okay, so to create a class, it's very simple to a structure. Classes and structures are kind of like kissing cousins, except classes are way sweeter. Structures are like the retarded cousins of classes, okay? So, to create a class, you say class, you see the name of the class, and you got some brackets, and you always put a semicolon on the end. Don't forget that semicolon. That'll fuck you over, man. Do it. Now, the first difference between classes and structures is you got a structure, and you create some kind of object off of the structure, like, where is it? Like poo. And then you want to access someone, like one of the members, like X, Y, Z. You can just access it. Like, let's say you got something like, now I gotta fucking type shit. Okay. You can create a poo, right? You go poo, poo. You go poo, the poo, right? And that's creating an instance of the poo structure. And then you want to go the poo, you want to access something, you just go the poo.x is equal to blah, whatever. And that's how it works. Now with classes, that's not how it works. Classes have something called access modifiers or restrictors. I forget the exact term. But anyways, you got stuff that's private and you got stuff that's public. Like look at this here in our game class. We got this thing here called private. So everything after this is private. What does that mean? Well, that means that anything that's accessing the stuff inside game can't access the private shit. That stuff is off limits. So only access is the public shit. So external stuff cannot access any of this private shit. All this is private. Well, the reason it's all private is because basically the game object is working inside of itself, right? But there is a public, there are some public methods in here. For example, Go has to be public. Why does Go have to be public? Well, if we go down to windows.cpp, this is where the game object is actually created. So the game is created here, and Go has to be called from outside of the game object, right? It has to be called to get the processing running inside of the game. So it has to be public. But all the other methods, they're called from within Go, so they can be private because they're called by the object itself. Private shit is only accessible by the object itself. Public shit is accessible by everyone. So, let's create, what are we going to do? Let's create some public methods here for our scoreboard. Now, this is where we kind of sketch out the basics of our class. Now, scoreboard has to be able to, we have to be able to save our scoreboard and load it. Now the question is, how do we want to do that? So, if we want to load a scoreboard, here's what we're going to do. We'll just do scoreboard. First lesson on classes, which is something you should already know if you've been watching my tutorials. If you have a member function here and it has the same name as the class, that member function is what is called a constructor, and it is called when you create an instance of the class, or you create an object of the type scoreboard. If you create an object of type scoreboard, the first thing that happens is this constructor function, member function, is called. So this is the stuff that happens when a new scoreboard object is born. So we need one of those. Second thing that you should also already know, whenever an object dies, it has something called a destructor, which is called. A destructor also has the same name as the class, except that it is prefixed with a tilde sign. So you've got these two functions here, a constructor and a destructor. What else do we have? We're going to need a... let me think here. Yeah. We're going to need a function which adds a score to the scoreboard. But unfortunately, we can't write that yet because we don't have a score object. So let's create a score object. Now I'm thinking, how do I want to do this? Add a score. Yeah, what we're gonna do. This is how we're gonna swing this situation here. Okay, so this score object, which sits inside of the scoreboard class, we're not even going to let the user of this scoreboard class be aware of the existence of this score object. So they'll never see a score object. They won't know what the fuck that is. So that means that we can make it private. So we'll go private, and we're going to create a class inside of a class. This is a class inside of a class inside of a class. You can't get much classier than that. And the class name will be just simple score. Yeah, score is good. Now score has some private members. Generally, all the data inside of a class is private. There are exceptions, but generally that is the case. So, as before, our score, where is it? So we'll have int score. And time. Now this time we're not going to make the time as a character buffer with a a static array. We're going to use a dynamic array. So we're going to do a car pointer to time. All right. So that means we're going to have to do a little messing around here with dynamic memory allocation, but dynamic memory allocation goes very nicely with classes, as you will see very shortly. So now we have a score class. We haven't defined much about it, but it's there. Now add score, because we're not letting the outside user know about our score class. Obviously we won't be passing a score to this function. We'll just be int score constant car pointer to time. So what'll happen is when we want to add a score to our scoreboard, we'll pass the data for the score and time, and what will happen is the scoreboard will create a new score object and add it to the list inside of the scoreboard, and the user, which is external to the scoreboard, will never be aware of what's going on inside of the class, which is a very good thing. This is what you want to be doing, trust me. Now, for public functions, this might actually be all we need. Create the scoreboard, destroy the scoreboard and add a score. Yeah, that's probably all we need for public functions. Getting back to privates, we're going to need a pointer to the first element in the linked list of scores. So we go score pointer to first score. There. That might be all we need. Look, we can add new shit as necessary, but for now that's fine. So what should we do? Well, we could flesh out the score object a little more. Public score. So when we're creating a score, we can create one from this data. Now I'm thinking, how are we going to insert this score into the list? First of all, we're going to need a score pointer to next score, right? Because in a linked list, every element in the list needs a pointer in order to link the list up. Now, the question is, should this element here be public? Because the scoreboard is going to have to be able to access these pointers in order to manage the order of the linked list. When it's inserting a new element into the list, it's going to need to be able to change these pointers. So how does that work? We've got an element here, we've got another element here. This one's pointing to here, but we want to insert this element. So how do we insert an element into the list? Do we need the scoreboard to be able to meddle with these pointers, or can these elements do it on their own and keep their pointers private? So what we could do is every score object could have a method called insert, and this method takes a pointer to a score pointer. So we pass a pointer to a score object to this method, and what this method does is it makes this object point to here and this one point to here. That's fine. I think that's what we'll do. So we're going to keep the pointer private. We're going to keep this pointer private. We'll make a I may be rambling on here. You might not understand everything I'm talking about, but don't worry about it. It'll become clear. Most of it will become clear. And the stuff that doesn't become clear in this lesson will become clear later. So, just follow along and try to figure out as much as you can. This is by no means supposed to be comprehensive and thorough, but I want to give you guys an overview of how to create classes just by actually doing it. Okay, so here's how a score object will be created. Destroy a score object. Now, there'll have to be a function to get the next item in the list. So that'll just return this pointer. And there'll have to be a function to insert an item after the current score object. So that would be void insert, and we have to pass it a pointer to a score object. Score. But it's not a good idea. See, because we also have score here, we don't want to have the names the same. You can have the names the same, it works, but it's not the best. In score? I don't like that name either, but it's better than just score. Score to be inserted. Alright, so here we create, this is for creating the score constructor, inserting a score into the list, getting the next score when we're walking the list, and the destructor for the score. That'll be good for now. We're going to need other functions. For example, we're going to need a function called serialize, and that will be a function for writing the score to a file. And another function will be unserialize, which will be reading from the file. Right, because there's two ways to add a score to the list. One way is by reading it out of the file, and another way is by adding it from data, from a new high score, or just a new score. So, that's a lot of functions. Let's see. Although serialize, how should that work? Score. So we can either create a score by passing it a data for the score, or we can create the score by passing it a file from which to read the data in. That's the unserialize. Now for serializing the score, for writing it to file, what should we do? We could do that in the destructor, in which case every time score is destroyed, it's written to a file. But then no, we couldn't do that. We can't do that because it needs a file. It needs a pointer to a file. So that is not possible. We'll have to do serialize. There. Void. Alright. So this one will write to a file. This one creates it from file. And that might actually be all that we need. We don't actually have to access the data in the score because we never use it inside of the program. We just write it to a file or read it from a file. Right? The way the user inspects the high scores is by opening the text file. So we don't actually need a method to access these private variables here. We just need to be able to write them to file and read them from file. We can do that. So this is probably all the functions that we need for our score object. And for our scoreboard, these are all the public functions that we need. We might create some private helper functions just for organization, but in general this is all we have. All right. So now it's time to actually write the functions, write the bodies of them. Now I could do it like we've been doing so far. I could go into game.cpp and let's see here. Let's say I wanted to write the constructor for our score object. I'd go game scoreboard score like this, and then I could write my constructor. But today we're not going to do that, because the other thing we can do is we can actually create our definitions right inside the file here. So we can just write this and that's fine. So that's what we're going to do today. There are advantages to splitting it up into a CPP file and an H file. But there are also advantages to doing it this way. So I'm just going to show you this way, because we've been splitting it up until now. And I want to show you guys something a little different. So how do we create a score given score int and a time string? Well, what we do is we first of all we just set score. Fuck. You see, now I named this score the same name as this, and that's not a good idea, because the problem is, how does it know which one we want to access? If we go score is equal to 0, does the 0 go into here or does it go into here? The answer is it goes into here. So what if we want to store into this score? We have to do this pointer to score is equal to score. Now this is it's a pointer that you have access to inside of member functions. So every member function is associated with an object, right? If I create a score object and I'm running a member function of that object, I have access to a pointer that points to myself, to this object, this instance of the score. So what I can say is I can use this pointer to reference myself, right? So I want the score, which is a part of myself, this one, and I want to set it with this score here. It's complicated, but you'll get it. So another way is just to change the name of this thing, this variable. But I'll leave it like this just to show you guys the this pointer. We'll be using the this pointer later on too. This. Alright. Now for time it's a little different. Because what? Well, we've got a constant character pointer here. And we want to copy this into our score object. So what we need to do is we need to create a buffer in memory to hold this string. So, and I know a lot of you guys are probably thinking, man, this would be way easier if he was just using the standard template string class. But I will be using that, but not right now, because I want to be able to show off some features here. So we're going to do this the old-fashioned way with C strings. So what we want to do is we want to first create a buffer that can hold this string. So we do, to create the buffer, we use malloc. We go time, fuck. Now these ones also have the same name. So I'll just fuck it. I'll just use this pointer. But generally you want to give these ones different names than what you have here. Some people, what they do is for their member variables, they go underscore score underscore time underscore next score. And that way you never have a collision problem. because these ones all start with the underscore. But I've never liked that style. Although obviously it does have its advantages. Alright, so time is equal to, and we go car pointer to malloc. Now we need to know the length of this string so that we know how much to allocate. Now there's a function called stringlen, and that gives us the length of a string. So we get the length of time, and we have to add 1 because we need space for the null character at the end of the string. So the length of this string plus 1 for the null character, and that will give us our our buffer. So now this pointer here, this pointer is pointing to a buffer allocated in memory. And now we just do string copy. We copy into our buffer, and we copy from our thing here. See, I'm using technical terms like thing and stuff because I want to be precise. Yeah, so this will allocate memory for our string and then copy it from here into our string object, or into the buffer, which is maintained by our string object. Alright, and now we have our string object almost fully initialized, except for one thing. What does this have to point to? Well, we don't know what it points to yet. So what we do is we just set it to null. Next score is equal to null. And that null just means that it's pointing to nothing. If you don't set it to null, it'll just have some random number and you won't know what that means. But if you set it to null, which is 0, look, define null 0. If you set it to 0, then if you're debugging or whatever and you look at it, you say, oh, that's a null pointer, I haven't set it yet. Whereas if you look at it and it's just set to some random number, you don't know if it's set to something or if it was never initialized or what. So you always set your pointers either to some, you want it to point to something specific, and if it's not pointing to something specific, you have to set it to null. Just do it. Always null your pointers. It's a good practice. So now we have the function that creates our score object. Let's have the function that destroys it. Now here, because we've allocated memory dynamically, we have to free it in here. So we go time, we go free time. And that's it. That's all we need to do to free this memory. Notice here that since we don't have this int score, or this constant car pointed at time as a parameter, we don't have to use the this. Because now it's not ambiguous. There's only one thing that time can mean. Whereas in this case it's ambiguous because we have this time and we also have this time. Right. So ambiguous case, you have to use your this pointer. Unambiguous, you can forget you can lose the this. Same with next score, right? This is unambiguous because there is nothing else that could be. So it has to be this thing. Alright. So now we have our score created and destroyed when we want it to be. Let's make a function that inserts a score into the list. Oh man, we could do this like really sweet. We could do this so sweet. We're gonna do it sweet. Alright. Alright, well, I've got some sweet ideas here, but it's gonna have to wait until tomorrow because I'm all tuckered out. So, when we return, we're gonna write this insert function, and it's gonna be awesome because we're gonna use something called recursiveness. Recursion, that's the word. We're gonna use recursion, and it's gonna be fucking sweet. Until then, I'll see you later, which will be about less than 1 second for you guys. Bye. Alright, I am back. And, geez, now I can't remember what I was going to say. Because it's only been like 3 days or what. Whatevs. Let me think here. Alright, I think we were just starting to write the insert function. And what I said about the insert function is that it's going to be recursive. It's going to use recursion. So, what the fuck is recursion? That is when a function calls itself over and over again until it reaches some terminating condition, and then it stops calling itself, and all the calls return. They unwind. And that's what it is, and that probably didn't make much sense to you. But if you watch, you might get an idea of what recursion all entails. So, stay tuned. Now, one thing that I've been thinking of, though, is it's going to be kind of hard to test this score class inside of our game, because we're not going to want to build the whole thing. We don't want to write the entire class and then start testing it. Ideally, we want to be able to write a few functions, then test them, then write a few more, then test them, then put shit together, and finally test it all together as a final working component. But that's going to be difficult in the game. So what we're going to do is we're going to create a new project. And it's going to be a console application, because that makes console applications make it easy to test shit out. We'll call it what do we call it? Component. No, we'll call it scoreboard test bench. Okay. And as usual, we want to check the settings. We want to get rid of precompiled header. We want to get an empty project. Finish that. Now we want to see if I can get this to fit inside my goddamn recording window. There we go. And add a new item. We'll get a CPP file. We'll give her the old main. Good times. All right. Now let's copy and paste our score class into the top of our file here. We could put score in a separate source file, but fuck it. We'll just put it all in the same one. Doesn't matter. It's just a test. And we'll copy and paste it back afterwards. I'll admit it's not the most you cocksucker, you're doing it to me. There we go. My goddamn Visual Studio is freezing up on me. Fucking Visual Studio. Alright. What do I want? No, this isn't good. Okay, I didn't want poo. You are not invited to this party. You go to hell. You go to hell and you die. And shift tab this mother. I think I shift tabbed it too much there. Class score, public score. That's good. That's good. Public. Here we go. These guys need to get tabbed over. All right. Now, let's add our main function. Void main void. There. And let's get some source files. Includes, I mean. Include stdio.h. We're going to need that one for sure. For the file. malloc. Just in case, I'll put the standard library in there too. I don't think we need anything else. No, we don't need anything else. So, alright. We're going to need to write our insert function. Now this is recursive, so it's the thinking, the I don't know, the methodology is a little different than a normal function. So what we want to do for insert is we pass a score that we've created. We've allocated on the heap. We allocate a score object on the heap. And then we pass that to our linked list of score objects. And every score object is going to check the score in this score, the insert score, the score to be inserted. It's going to check that. It's going to compare it to its own score. And it's going to determine whether this score should come after itself or before itself. All right. Ow. So, how is this going to work? Bool. This insert function has to return a bool. And the reason why will become apparent relatively soon. So, the first thing we do is we go if in score, pointer to score, is, so we want the order to be from largest score to smallest score, right? Largest score at the top, crappiest score at the bottom. So if in score is less than, yeah, the score is smaller than the current score, then what do? Then we call insert, and we call it on the next score object in the linked list. So we don't do insert, we do, what did I name? I think I just named it next, right? Score pointer next score. So we go next score, pointer to, it's not coming up, but whatever, pointer to insert, and then we pass the in score on to the next one. Right? Is that correct? I do believe so. If it's smaller than this one, pass it on. If it isn't, Alright, I think I figured it out in my head. Now let's see if I can explain it to you guys. So, we've got a linked list of score objects, and they contain basically two pieces of data. They contain the score here at the top, and they contain a pointer to the next object in the list. They also contain the time, but we'll forget about the time. It's not important. It's just extra cargo. So let's create, we'll say we have a linked list of three score objects here. So this one points to this one points to this one. All right. And their scores are 12, 7, and 2. Now we have a score, and the score is 5. And we want to insert this one into this list. So what we do is we call the insert function of the first element in the list, and we pass to it this a pointer to this score. Now it compares its score number to this one, and it says my score is bigger than yours. So what it does is this one then calls insert on this one. Insert. Inert. Insert. There. And then inside the insert function here, it goes, yeah, I'm bigger than you. So it passes it on. And it calls insert on this one. And this one says, I'm not bigger than you. So what it does is it returns to this one. And this one knows that, okay, I'm bigger, but the one after me is smaller than the score to be inserted. And so then in here, it has to figure out, okay, we need to insert this one into here. So it makes its pointer, let me just show you here. It makes its pointer point to this one. And it makes this one's pointer point here. And then it's inserted into the list. Now the trick is, how do we get it to figure out when we have the situation where this one's bigger, but yet the one after it is smaller? And the answer is in the return value, right? When this function returns, it has to give a return value of saying this is the right spot. Whereas when this one returns, it has to give a return value meaning not the right spot. So here's how that works. So if the score is less than, then we call insert, and we're going to do some other shit, but we'll figure that out later. But else, if it's not larger or if it's the same size, let me think here. No. Yeah, so if it's smaller than or equal to, then we move on. But if it's larger, if the score to be inserted is larger than the current score in the list, then we return true. True means that, in this case, true means this is the right position in the list. There. All right. Now, in the case where the score is smaller than or equal to, we call insert, but we don't just call it, we check the value. So we go if insert, I'll just put in here equals to true, but you don't have to put that, obviously. So if that's true, then that means that this is the correct location to insert the score. So then we go in score dot pointer to next score is equal to next score. That's the next scores in the current object. So we make, that's doing this, right? That's making, that's making this one point here, right? Because this one's pointing here, and we take that pointer value and we make this one also point here. And then we make this one point over here. So to do that, we go next score is equal to in score. There. And now we have inserted it in our list. And then we return false, right? Because we have to tell, let me think here, go here. We have to tell this one now that you don't have to insert it in here because it's already inserted in here. If we return true here, then we'll get something really fucked up, because then we'll have like this one pointing here and this one pointing here and then this one pointing here. It'll be all fucked up. So we don't do that. Return false here, return true here, because this is where the new element is going into the list. So we'll return false, else if the insert obviously if the what, the return value of insert was false, was not true, then we just also return false, because that means that it was inserted somewhere lower down in the list. So we're all clear. All right, and that is our recursive insertion algorithm stuff. Now the trick is, can we get it to work? Scoreboard, score pointer to first score. This one goes over here. You do that now. Add score. Okay, I'm gonna write a just a void test, just a test function here, because our main can't access our score object direct. Oh, it could, but it's not allowed to. It's not supposed to. Let's make score private, because it's, wait, fuck. I fucked it up kind of, didn't I? Because I didn't copy the whole goddamn shebang. I only copied score, but I didn't copy scoreboard. And that's why my my shit was all fucked up before. Okay, now I know what's going on. Let's copy the whole damn thing here. Yeah, I missed copying scoreboard, because I kind of derped out there. That would be why shit's fucked up. And now my Visual Studio has frozen up again, because it's being a total dick. Do I have to pause this video? I will pause this video. I won't pause it, because then the audio is going to get all desynced. Fuck. Okay. There. Now I have to do stuff to make this all unnasty again. Okay, you go there, you go there. Now I gotta get class score. Where does that go up to? It goes up to here, right? Shit, I gotta tab that over. That's tabbed. And this one is... okay, I think that's good. Okay. Back to what I was talking about before I realized what I was fucking up here. I'm just going to minimize these functions. Okay, I want to write a test score, because our score class is private inside the scoreboard, so we can't test it out in here. We can't say score the score. Right. We can't do that because it's private. Arrow type. I might be fucking something else up here too, because my IntelliSense is not working properly. But anyways, let's not worry about shit being fucked up. Let's write some code. Okay, now I want to write a test that that basically just creates a linked list for this thing here and inserts a couple of items into the linked list. So we're going to ignore this first score pointer. Or not, we can use it, doesn't matter. First score is equal to new score. And we'll put the score as at 100, and the time is hammer time. Alright. So now we created our first score. And now I cleared my throat. Now let's add another score into the list. How do we do that? We go first score pointer to insert new score, and this one's going to be 50, and this one's Miller time. And then we go first score, pointer to insert, new score, and this one will be 20. And time to, I can't think of anything. It's midnight. Time to go to bed. Time to go bed. Yeah, that's what it is. I've degenerated into caveman speak. First score, pointer to insert, new score. And let's insert one between 50 and 100. So we'll put 70. And the time is foo, because I'm sick and tired of thinking of shit. This is as far as it goes with me. Okay, so we're gonna try to insert these times into our linked list, and we're gonna see what we can see. So I'm going to put a breakpoint here. And I'm just going to step through everything and just to make sure it all works properly. Now here, we got to create a new scoreboard. So scoreboard, board, and board.test. We'll run our test here. Go. And yeah, there's errors. Of course there was errors. String length and string copy. That would be because I did not include string.h. Build. Son of a bitch. Referenced in main. I didn't define my constructor and my destructor. Alright, let's define our constructor and our destructor. There. No, fuck you. There, you happy now? Go fuck yourself. Finally. Let's do it. Okay. I want to see my thing, but I also want to see the... Fuck. Damn it. Okay. You guys aren't going to be able to see this very much. Unless I'm like super clever. I can like move. You don't need to see this because there's no output. That's right. Okay, don't worry about it. Just look at the pretty lights here. I'm going to step over this one. So now first score points to a score object. The score object's time is hammer time, and the score is 100. And the next score is just zeros because there is no next score. There's only one score in the list. Now we're going to insert a new score. Now let's hope this doesn't fuck up. It fucked up. Fucking son of a bitch. I kind of knew that might happen. Okay, what's your problem? In score, pointer to score is less than score. What's your problem, man? Man, what's your problem? Miller time. Well, what's the this? Why does this? What? Why is this a pointer to nothing? Oh, right. That's right. Okay. I forgot one very important case in the linked list recursion thing, and it was very stupid of me. Yeah. So what this thing does is it keeps checking the next element in the linked list, right? But what happens when it gets to the end of the linked list, right? Because if you reach the end of the linked list, at the very end of the linked list, this pointer is null. It points to nothing. But in our algorithm, it's going to try to call this insert. It's going to try to call insert on a null pointer, and that'll just fuck up, right? So that's why our this pointer was 0, because we tried to call insert on a null pointer. So we got a null this pointer, and that fucked us up. So the trick is we got to check first. Man. Now I have to do another if here. There's so many fucking ifs. Fuck. Okay, if next score is not equal to null, meaning if we actually have another element in the list, then do this. Wait. Yeah, then do this. Call insert on that element. Or if we're at the end of the list, let me think. Yeah, if we're at the end of the fucking list and we still haven't found anything, if we're at the end, then just cram that score at the end of the list. So how we do that is we say next score is equal to in score. Right? And that's all you got to do, right? And then return false because we've already inserted the element, so all the other functions upstream don't have to do anything. All right, yeah, I forgot about that case, which was actually critical and very important and stuff. Balls. Okay, let's build the solution again, and let's run it again. And let's step over this one, and let's step into this one. Oh, we don't want to step into that. Step out of that. Step in here. Yeah, here's where we want to go. Good. So we allocate, we call the constructor for score. We allocate it up. And we go back. And now that we've created a score, if I step in, I'm going to go to insert. So first we're going to check to see if in score, we're going to check to see if the score is smaller than the current score in the list. And it is. So now we check to see if there's another score down the list. And there is not, because there's only one score in the list. So that means that we stick the in score, we tag it onto the end of the current score. So next score is now equal to the insert score, right? Which is Miller time. And then we return false. Good. Now let's step in, out, in, out, in. There we go. Now we check to see is the score smaller than score. And this time it is also smaller. Now we check to see if there is a next score in the list, and there is one. So now we call insert on that score. We step in. And we're back to the beginning of insert. But this time we've called it on the second one in the list. So now we check to see is it smaller, and yes it is. And is there another score in the list? No, there is not. So tag it onto the end. And now we return from this first call to the second call to insert, and we check to see is it true, meaning is this the place where we have to insert? And no, it's false because we already inserted it at the end of the list. So then we return, and fun is had by all. Now we step in, out, in, out, in. Okay, so is the score smaller? Yes, it is. Oh yeah, I did another one that was smaller. Okay, do we have a next score? Yes, we do. So let's call insert on that one. Score smaller? No, the score is not smaller because balls. Now I gotta look for it. Here it is. Yeah, so the last one I inserted was a 70. 70 is smaller than 100, but it's bigger than 50. So the second time we called insert, the smaller than test was false. And that means we return true. We return true to this first one saying, okay, you got to insert that bugger after you. So now this will return true. Blah. Step over? Yeah. So that means that this call is true. So we insert the score after the current one here. Insert that in there. We shuffle shit around. And shit is good. And now we've finished our test thing. We've inserted 3. We added a score here and then inserted 3 more into the list. And now if we look at the list here, we have first score 100. Next score 70, 50, and 20. So you see they're all ended up in order. Even though I inserted them out of order, they ended up in order because of the magic of recursion. And I only fucked it up kind of once. But I fixed it. Alright, so that is recursion in a linked list. It's kind of complicated actually, but I'm sure if you input the code yourself and then you step through it like I did and you watch what's happening to the variables, you should be able to figure it out. Now, so that means that our inserting function is probably working, except for one little problem. And that is, what happens if we try to insert an item, like let's say we insert something that's value 15 into this list. Well, it goes before the first element. Now, how do you do that? Well, that means that the class which actually holds the entire list has to change its first score pointer. So that means scoreboard, which is going to call, eventually scoreboard is going to be calling insert on the first score. And what it has to do is it has to check the return value for insert. And if the return value is true, then it has to shuffle it has to insert the score into the first score position. So first score will point to the score. And then the score will point to whatever first score is pointing to. But that's a problem because you see the insert function is a member of score. So it can access the next score pointer. But scoreboard is not, I don't think scoreboard is allowed to access, it's not allowed to access next score pointer. And that's a problem. Because if we're going to insert this one into the list, we make first score point to it, but we also have to change its pointer to point to the old first score. So this one points to the old first score, and then we change first score to point to here. But we're not allowed to touch this one from our scoreboard. And it was so perfect until I had to do that thing. Balls. Alright, I figured out a solution that will allow me to not have to let scoreboard access next score. And the solution is a little devious. So in the case where where insert returns true, let's just go back to our diagram here. So insert returns true when we reach a node or an element in the list that will come after the element to be inserted, right? So I mean, in the case where the element was 5, let me just back up here. Whoa there, Nelly, back up. In this case, insert from this one would return true, right? This one would return false, and this one would return false, right? So that's because this one is the element that will come after the element to be inserted. So it returns true. Now what we're going to do here is we're going to be sneaky. And in this insert function here, we're going to return true, but before we do that, we're going to set score point, wait, we're going to set in score pointer to next score, what? Next score is equal to this, right? And that makes sense because it's going to, if the current element in the list is going to come after the element to be inserted, then that means that the element to be inserted will have to point to the current element. So we'll do that in here, in the actual, in the insert call where we discovered the element that comes after the element to be inserted. We're going to make it point to this. So we do that here. Because we're doing it here, we don't have to do it here, right? So if this one returns true, then we just have to make here, let me go back to the diagram. If this one returns true, then we just have to make this one point here instead of pointing here. So we switch the pointer from here to here. But we don't have to touch this one's pointer because in this insert call, we set this one's pointer to here. Yeah. And if we do that, then that means that, let me just check it out. Go back. Go here. Z. I don't want to undo that shit. Why? Yeah. So that means that, for example, in the case, let's get rid of this here. Put that like that. In the case where this is 15, right, and we're inserting it into here, we're going to compare it, and this one's going to say, oh, I come after 15. So it's going to immediately return true. But before it returns true, it's going to set 15 to point to here. And because 15 will point to here, now the scoreboard will not have to access this pointer. It doesn't have to touch the private parts. Don't let strangers touch your private parts, boys and girls. Remember, stranger danger. Alright, so with that problem solved, life will be complete. Or something. I don't know. Fuck it. Just fuck it. So we're not gonna... We'll leave test as the way it is for right now. Now we're gonna delete test. Test smells like a bag of scrotums. And instead we're going to go to our scoreboard function here. Our constructor. And we're going to say, what? Next, no. First score, null. So we initialize first score to null. Because we always initialize our pointers to null. Because we're good boys and girls. And now, in add score, so this is the function that the client or the actual user of the scoreboard will call to add scores to the scoreboard. And how that will be done is we go if first score is equal to null. So if there are no scores in the scoreboard, then first score is equal to new score score time. There. Very simple. We just set it equal to a new score. But if there are scores in the list, then we go first score pointer to insert new score score time. Did I explain this new? Fuck, now I can't remember. I don't think I explained new yet. Shit. I'm gonna have to explain new. Alright. So new is like malloc, but it's for C++. And what it does is if we go new score, it will allocate space on the heap for a score object, and it will return a pointer to that space on the heap. But whereas malloc just allocates space and returns a pointer, new allocates space, then it calls the constructor for that object. It calls the class constructor, passes it these parameters, and after the constructor is finished, then it returns a pointer to the newly constructed object. You can allocate space for a score object using malloc, but malloc will not call the constructor. So it will be an unconstructed object, and that's not good. So whenever we are allocating memory for objects, we have to use the new operator. Now, the thing is we can use the new for anything. We could do this time is equal to new, and we could create an array of characters. We could do a new array of characters. So that begs the question, why should we use malloc anyways? And the answer is we shouldn't. I just used it because we've been using it up until now. But from now on, we're not going to use malloc. And the reason is, well, the main reason is because everything that you allocate with malloc, you have to destroy with free. And everything you allocate with new, you have to destroy with a operator called delete. You can't mix them. If you allocate with malloc and destroy with delete, or if you allocate with new and destroy with free, you will fuck up your program. And it can be tricky to remember which pointers were allocated with malloc and which ones were allocated with new. So the easiest solution is just pick one and stick with it. And we're going to pick new because new calls our constructors. So say goodbye to malloc because this is the last time you're going to meet this guy. So it's just a kind of one last time for old time's sake or something. I don't know. But yeah, that's new. It's just heap allocation and constructor calling. Okay, so we call insert, but we have to check the return value. So if insert, wait, yeah, is equal to true, then that means that we have to make first score equal to fuck. Not equal to fuck, but we have to remember the pointer to this new score because we might have to make first score point to it. So we go score pointer to new score is equal to new score score time. There. And then we pass that new score to our insert function. And then if it's true, we make first score point to the new score. And if it's not true, then we just do nothing because it's been inserted somewhere else in the list and we don't have to worry about it. And that is the add score function. That will add a score into our list sorted properly. This is all sorted, baby. And so sexy. All right. And now we have a problem because we've been allocating all these scores. We've been allocating them on a heap. But when we destroy our scoreboard, we do nothing. So all these allocated scores, they just stick around on a heap, taking up space. So we got to delete all our scores and stuff. So what we do is we go delete. Wait, don't do that. First we check to see if there's actually any scores on the list, in the list. So we go if what? If first score is not equal to null. Right. If it's not null, then delete first score. I mean, if it is null, then we don't. If you call delete on a null pointer, your program's gonna throw a shit fit. So we only want to try deleting shit if there's actually shit there to be deleted. And after you delete a pointer, or after you free the memory that a pointer points to, it's always a good idea to go first score equal to null, just to be safe. There's no real reason for it, because we're going to destroy the scoreboard right after this. It's going to die. But just to be safe, whenever you delete, null. And that's just good practice. Just one of those habits that you got to form. I don't know where I want to put this. I'll put it there. Fuck it. Okay, so that's our destructor. But the problem is, let's say we have something like this, where we've got a bunch of items in the list. We delete this one, but this one still chilling out in our heap, taking up space, eating our Doritos. We got to do something about this. So what we do is in the destructor for our score, we free the memory allocated to the string, the time string, and then we do something sneaky. We go if next score is not equal to null, meaning if there is a score after this one, delete that one too. Delete next score. And we'll make our pointer then point to 0. No. So now we have a recursive delete, because let me show you. When we call delete on this one, it calls delete on this one, and it calls delete on this one, and it calls delete on this one, and then this one gets destroyed, and this one gets destroyed, and this one gets destroyed, and then this one gets destroyed. So it's a recursive memory deallocation, and that is also very sexy. These are all very sexy things, people. Yeah. So we don't want to call test, but we do want to call add score. Now I'm going to add a test. Before I actually test this, I'm going to add a test function to our score thingamajig. And so we'll put it right here. We don't need this. Actually, this next, we're never going to use it, so we don't need it. We go void test, and what we'll do is we'll go printf %d comma %s, and we'll print the score and the time. And then we'll also if next score. So if there's something at the next score, if it's not 0 basically, then call next score, fuck you, score pointer to test. So this is a recursive test, because everything's recursive in this scoreboard, because recursion is kind of sexy. Okay. So, my friends, now we call that test. Let's call this test too. We'll make this test. Making a test. Void test. If first score, then first score, fuck you. Pointer to, damn you, test. Okay. Now we go scoreboard. And then we go board dot add score. So let's add 100. Hammer time. Hammer time is one word. I think it's one word. And we got Miller time. That's 2 words. Fucker. What should I do? I'll put one in between hammer time and Miller time. We'll call that one Vader time. What time? It's time! Alright. 20 is, I don't know. Whatever. And board dot add score 150, because we've got to test that special case, right? I have no idea. Foo. Okay, so we add a bunch of scores to our scoreboard. And then we call board.test. And we test it out. Let's check this out. Well, first let's build it and make sure, because we're going to get errors. Of course we're going to get errors. I always get fucking errors. Fucking errors up the ass. This is sketchy. Too many brackets. Too many parentheses. These are called parentheses. Alright. Well, that was easy. Okay. Now let's see if it fucks up. Actually, it worked pretty good. Let me just wait, because my fucking Visual Studio froze up again on me. Why does it do this shit? Why do you do this shit to me, Visual Studio? I gotta try out Visual Studio 2012 Express, because it might not fuck me over so bad. I know if I pause the video it'll be good, but if I pause the video it'll introduce a slight delay from the audio and the video. It will very imperceptibly desynchronize. Every time I pause the video, I get a little bit more desynchronized. At least that's my theory. And this is the longest it's ever... Fucking, I'm pausing the video. Fucker. Okay, so what I wanted to do was go to test here. Because that was ugly the last time. That was butt ugly. Okay, here we go. So here we have, after we called test, it recursively runs through the linked list from top to bottom and causes every one of those linked lists to print out its data. And as you can see, all the data is there that we inserted, and it's all in the proper order, because we inserted it out of order, but it ended up in order. So that means that so far our board is working fine. We can add scores to the board, and those scores are inserted into the correct order. And as far as we know, when the board is destroyed, it deletes all of the scores properly. I haven't gotten any errors, so I'm assuming that they all get deleted properly. So we're getting somewhere with our scoreboard class. So now we can create scores. We just insert. I'll delete this test later on, but I'll leave it in for now. Just might come in handy later. Alright. Scoreboard initialized just by that. Deleted by that. Add a score test. Okay. So now we have the basics of the scoreboard, but we need to put in the important shit, which is we have to be able to save the scoreboard to disk, and we have to be able to save it to disk, and what's the other thing? Load it from disk? Yeah, that's the thing I was trying to say. But it is now 12:18 in the AM, and I am getting tired, so I'm gonna stop the video again. And fuck, this video's getting long too, but fuck it. Just fuck it. I'm gonna stop this video, and when I come back, we are going to finish this class by saving and loading, and once we've got it all set up, then we will reintroduce it into the game and do some final touches. After which we're going to have sexy times. So, see you in 1 second. Fun fact, this is actually the second time I'm recording this next part here. So yeah, I recorded it once, and then I looked at it and I said, this is bullshit, and I deleted it. So let's try this again, and this time let's hope I don't fuck it up. I mean, not that the other shit is any great shakes either, but geez. Okay, so now what we want to be doing is we want to be able to write this mother to a file. And we're going to do that recursively, just like in our other cases. So the function for that is serialize. And what I'm going to get you guys to do is go back to our, where is it? Go back to our PooFace EX plus alpha. The file where we had our original scoreboard function stuff, and we're going to use this code over again. So let's go to no, not save games, get score, save scoreboard. That's what we want. So we're going to use some of this. Specifically, we're just going to be using this one. We don't need the loop, right? Because we're doing it recursively. And generally, recursion and loops are an either-or thing. Recursion replaces loops and vice versa. So we're replacing this loop with a recursive function. But we need the actual body of the loop for our recursive function. So we'll do that. We'll get rid of that. Okay, so we'll put this in here, but we need more than that, right? We're gonna need a terminating condition. So it's very simple. First, if we call serialize on our element, our score element of the linked list, we need to use this file here, and we want to print out the current score element itself. All right, we'll get back to this. This index, this is a problem because we don't have a loop, so we don't have an index. So we'll get back to this. But beyond that, scores index score. All right, we just want score, right? Because that's the name of our score variable in the score object. Score. That's a lot of scores, and time is, I think it's just time. So there you go. So that's that. Now, this index is a problem because we don't have an index, we don't have a loop. But what we can do is in this serialize function, we can pass it an index. And then we can print out index plus 1. I'll leave the brackets here. Not necessary, but oh well. Alright. So first thing we do, we print ourselves out into the file. Then we want to call serialize on the next item in the list. That's the recursion part. So we go if, what is it? Is it next or is it p next? Next score. Maybe I should have called it p next score, but whatever. I hope you guys realize that if next score is exactly equivalent to if next score is not equal to null, this and this, these are identical. So if you don't understand how that works, then you should probably study up on your if statements. Okay, so if we have a next score, then we want to call serialize. We'll use the same file object, and we'll call it with, I'll do it again, index plus 1. So if we call the first one with index of 0, it'll print out a 1, and then it will call serialize with 1, and in the next one it'll print out a 2, call serialize with 2, and then print out a 3. So every time we go one step deeper in the recursion, this index gets 1 larger, so we get our index that way. And that's it. That is all we need to do to serialize recursively. Now, the trick is the last little bit of this puzzle, if you will, is we need somewhere to open the file and close the file. We don't want to open it and close it on every step of the recursion. We want to do it at the beginning of the recursion. We want to open it. And at the end of the recursion, we want to close it. So the opening and closing will be handled by the scoreboard class, right? Which encapsulates the score list. So we go scoreboard serialize, and we'll put this file open here. Then we check to see if first score points to anything, because if it doesn't point to anything, we have an empty list, in which case we don't want to do anything. But if first score does point to something, fucking IntelliSense, probably doing something stupid. Anyways, if it does not point to anything, we do nothing. If it points to something, we call serialize. Serialize with our P file. And then we go F close P file. And that's it. That's all we need to do to serialize. Now, fucker. 1 second. Alright, I just had to type this shit back in here again because I deleted it last time. Kind of stupidly. But, yeah, I didn't want to make you guys watch that. Now, we've added a bunch of scores to the board. And now we want to, I guess we'll call board.test. We'll print them out. And then we'll call board.serialize. What's that? Serialize. And that should write them to a file. It might not work. I might have a bug in here somewhere. Okay, a failure. Scoreboard serialize does not take one argument. Right, it doesn't take one argument. It's because it has an index. So we start off with index 0. Alright, so, and we stopped working. So I've done something stupid, obviously. Probably somewhere in the neighborhood of our recursion here. Way to be! Okay. Where's my serialize? Here it is. No, there it is. There we go. Okay, what's the problem, brah? If next score is serialize. That was incredibly retarded. So I'm calling serialize recursively, but I'm calling it on the current score element, or whatever you want to call it, the linked list element. So I'm calling serialize on the current element over and over and over again, when I should be calling next score pointer to serialize. That was not a good mistake to make, but easily caught. And now we have, looks like everything's in the proper order. Let's check out our file. Test bench, we go here, we go highscore.txt, and there we go. We've got our file all printed out neatly and in the proper format, in the proper order. So that's how easy it can be. Now, the next thing we want to be able to do is load a scoreboard from file. Now this is going to be a little tricky. This might cause us some problems. 1 second. Now we could create a function called unserialize, and that would be the counterpart to our serialize, but we don't need to. We'll just create another constructor here, and this constructor takes a file object, so it constructs from file, and that will be basically our unserialize function. And this constructor will also be recursive. The constructor itself will create another object of its own type and add it to the linked list, as long as there are still entries in the file. So, let me think here. Well, let's look at what we had before. That'll be our starting point. Load scoreboard. Now this while loop here, which keeps loading until index is less than n score, or until we reach the end of the file. This isn't proper. This will not work. This use of fseek, the return value of fseek, does not tell us if we are at the end of file or not. It's not the way it works, apparently. That's what I fucked up in the first time I tried recording this video. I was mistaken as to how fseek actually works in terms of its return value. So, what we want to do is, well, we want to do something that's very similar to this, but not quite. Well, we're going to need this for sure. So let's just start off here. The meat of our loading is going to be using fscanf, right? So we'll copy this, copy that, paste it here. Now we're going to load our score from the file. And we're going to load our time, but we can't load it. We can't load time directly into our pointer because our pointer doesn't have a it's not pointing to any buffer. And we can't create the buffer until we know how long the time is, unless we want to waste space. But we can't load the time until we have a buffer. So we create a temporary buffer, just statically. We go car buffer, and we say, well, we're not going to have anything longer than 128 for our string. We assume that. Is it the best thing to do to assume these kind of things? No, not really. But we're going to do it anyways. We need the address of score. We need address of stuff for scanf, right? Buffer is an address by itself. So we load the time into the buffer. Then we create our actual buffer on the stack, our block of memory to hold the string. And how we do that is we go time is equal to car pointer to malloc, and I'm not getting my IntelliSense again. Always fun. Yeah, malloc size of, no, we don't need size of. what we need is strlen. We need the length of the string in the buffer. Fucker. Buffer. The length of that string plus 1 for the null character at the end. That will get us our string length. Now we have our time buffer allocated to the exact size of the string. So now we can do string copy. And we copy to time from buffer. And that gets us our shit all loaded up. But that was the easy part. Now the hard part is getting to the right place in the file stream and checking to see whether there's anything left in the file stream, whether we're at the end or not. So in order to do that, I haven't actually tested this out, but I have a theory. So normally we have to seek 5 forward to get to the correct position for the next reading. This initial seek of 3 will be done outside. This will be done by the scoreboard class. But inside the score class we have to do all this stuff. What we're going to do is we're going to seek forward 4 characters. We seek forward 4 characters. 4. And then we call f get ch. Fuck. Is my IntelliSense fucked or what? No, it's working. Okay, so f get c. Yeah, that's one. And we call that on our file. This is p file, no good. P file, no good. No, that wasn't good. Said, copy, paste. Alright. Now, so we seek forward 4, and then we call f get c for the final character. And f get c will set something up for us, because there's a function called end of file, end of file, and this will tell us whether we are at or past the end of the file. But the problem is that if you call fseek, that will reset the indicator for the end of file. So we can't seek forward 5 and then check end of file. That doesn't work. Which, personally, I think that's fucked up. But whatever. So we have to seek forward 4, then call f get c for the final character, and then check the end of file status. This is my theory. I haven't tested it out yet. I could be talking out of my ass. So what we do is we load the current data from the file. Then we seek forward. Then we check to see whether we're at the end of the file. If we are not at the end of the file, then we go next score is equal to new score, and we pass it our current file object. New score. Did I talk about this yet? I can't remember. Oh yeah, I did. Wait, did I? No, I can't remember. Insert. Yeah, I think I talked about it in insert when we did the new... What? Where is it? Or maybe we did new in here? Shit, now I can't remember. 1 second, add score. Yeah, here we go, new score. Okay. So, I hope I talked about this new operator. It's just the same as malloc, right? That was like a week ago, so you'll have to excuse me if I don't remember exactly what I talked about. So we create a new score, and we make next score point to that, right? And this is also recursive, so this new score might create another one, and that one might create another one, and we'll get a whole list of scores based on what we had in the text file. Or if we are at the end of the file, I can't remember if f end of file returns non-zero for end of file or non-zero for not end of file. Fuck. I think it's non-zero for the end of file, so we want if not end of file, make another score. Otherwise, next score is equal to null. So set it to 0 to show that this is the end of the list. Alright, now this should work, but I doubt it's going to work on the first try. It just, shit never works on the first try. Except when it occasionally does. Okay. 1 second. Alright, so non-zero value in the case when the end of file indicator is set. So it's non-zero if we are at or past the end of the file. So 0 is returned when we are not at the end of file. So we have to invert that 0 to do this, and okay, that's good. If not end of file, do this, otherwise do this. Right. Yes. Okay, so now we have to if I was a good programmer, I'd put something in here like need to set EOF indicator for FEOF call or something like that. Just like people who look at this code might be like, why the fuck is he seeking and then F getting C but not using the return value of F get C? He's smoking crack. These are the times when you add a little comment on the file. Whatever. Stuff. Let's use this in the scoreboard thingamajigger. So we'll create a new scoreboard constructor, and we'll do constant car pointer to file name. Okay, so now we have to do the other shit that needs to be done. Namely, we have to open the file. So we'll do that here. I'll just leave it highscore.txt. No, I'm not going to use this file name thing just yet. I'll use it later. Later. I'll use it later. Yeah, we'll forget about it. We're going to hard code the file name in there. Later on, we can change it if we want to. I might not even bother. For now, hard coding is fine for me, for the purposes of this exercise. But let's get back to business. I'm not even going to check to see if the file exists. Okay, I'm just gonna assume that it worked and go from that. I don't give a shit. Normally you should check though. So we open the file, we seek to the starting position, and then my friends, we do what? Well, normally we would check to make sure we're not at the end of the file. I should do that. In case we've opened an empty file. So we should seek forward to, then call F get C. Fucker. P file. What? I don't even know why that happened. Scoreboard is already defined. Ah, right. I create, okay. You can't have two constructors with the exact same parameters. That's just stupid. So, constant car pointer to file name, which we will never use. Or maybe we will. Well, we got success, but at what price? Alright, so if not f end of file what? File. P file. I had a brain fart there. A little gassy today. Yeah. So if we are not at the end of file, then we say the first score. Yeah, first score. First score is equal to new score file. P file. Otherwise, we had an empty file, so that means we need an empty list. First score is equal to null. And finally we call f close on p file, and we're all set to go. Now this should sort of work. Delete that. Okay. Now I need to think. Let's just build it, make sure I don't have any errors. Okay, success. You piss me off with your goddamn warnings and shit. I like to live dangerously, on the edge. Okay. So we comment this, we open up our board, we create a new scoreboard, but we call it with file name. Yeah, okay, gotcha. File name. And this is a dummy name because it's not going to be used, so we'll just call it with dummy. That'll load the board recursively. Now we can call test. We won't bother calling serialize because it's already written onto the thing. So this is probably going to fuck us up. Let's fuck some shit up, people. Let's have one last look. Not that I'm going to catch anything. Well, might as well just dive in. Alright, so how are you gonna fuck me up, program? What? It exited. Did it actually work? If that worked properly, holy shit, that worked. It worked on the first try. You can see how surprised I am that that actually worked. So, at least like my theory was correct. If we use f get c together with file end of file, we can detect when we've passed the end of the file. What I would prefer is that if fseek set the end of file indicator, so I could just do fseek 5 and then check f end of file. But it doesn't work that way because whoever wrote it is probably a retard. I'm joking. They probably had their reasons that us mere mortals could never fathom. But anyways, that's how it works, and it works fine. So now we can load and save our scoreboard. Now what I'm going to do is I'm going to fix up that thing so it uses the... I'm going to fix up the constructor so that it uses that string that we passed to it. So in that case, our score... Shit. Damn it. Now the way I want to do this is... There's a very specific way I want to work this, but... You know what? Fuck it. No. Now I gotta think. Wait, let me pause the video. Alright, let me explain my woes to you guys. The problem that I have. So if I make it so that the scoreboard here can accept a file name and use that file name, the scoreboard also has to store the file name in here, because it has to use the same file name when it saves as when it loads. But the thing is that when we save our scoreboard, we're not going to use the serialize function. What happens is we are going to use the destructor, and we're inside the destructor we're going to call serialize. So whenever we destroy the scoreboard, it'll automatically save itself. That's what I'm going to do. But the problem is that the destructor can't take any parameters, so we can't pass it the file name to save to. So it has to remember its file name inside the object. Okay? You're with me so far. The problem is that if we create the scoreboard, not from file, but just an empty scoreboard, we also have to pass it a file name because it needs to know what file to save itself to when it's being destroyed. And we can't pass it the file name because it's going to be destroyed from the destructor, and destructor can't take any parameters, right? So this one also has to be, god damn it, it also has to have this signature. But if we have two separate signatures, they have to be different. We can't have two constructors with identical signatures because the compiler won't know which one to call when we type it out. So that won't work. But I have a solution. We'll merge the what? We're going to merge the function, the constructor of an empty constructor and constructing from a file. We're going to make them just the same constructor. And what we're going to do is, in either case, we're going to have the constructor attempt to open the file. So it's going to attempt to open file name, and then it's going to check to see whether p file is actually valid. And if it is valid, then we do the construct from file routine, and if it isn't valid, we do nothing. And in the initializer, we do what is it? First score is null. So we initialize first score to null, and then if we can open a file, then we load it. If we can't, we just leave it null. And that way, we can get away with just one constructor that does everything we need. That's a better solution all around. That's the best solution. I should have done that solution from the beginning. Now, that should still work. I mean, it won't work, but it should still compile. And it compiled, so that should be good. Let's highscore.txt. Let's try that. Okay, so that works. That works fine. Now, but now there's a problem. If we want to create a new scoreboard, we can't do one. We can't reset the scoreboard because it'll always load from the old one. Unless we put in a function clear scoreboard. Okay, so it's still possible if we wanted to do it. We don't want to do that. We don't want that functionality, but if we ever decided we needed it, we could easily add it. What was I going to do? Right, I was going to go here and delete the high score. Yeah. And now we're going to try to load high score when there is no high score. Let's see if it crashes our program. And it doesn't. It just, we print out, we do test, and it gives us empty shit. And now if we uncomment this, it still works. We can add shit. And if we uncomment serialize, that'll give us our scores here. And we should have our file now. Highscore.txt, and there it is, and they're all set up properly. And then if we uncomment these ones here for adding scores, we should be able to load it and do the test and then write it back to the thing. And we loaded it properly. And if we open the file again, it's good. It's all good. Yeah. So, this is way too wide. There we go. So, that's working fine and dandy. Now we have to remember the score, the file name that we get passed in the constructor. We have to remember that file name. So we go, first we add another variable to this thing. We go car pointer to file name. Ah, damn it. Which is going to be the same here. Whatever, fuck it. We'll make use of our this pointer. Okay, so what we do is we go this pointer to file name is equal to car pointer to malloc. And I'm not getting my IntelliSense, fuckers. String length of file name. This file name is this one, and this pointer to file name is this one. It's tricky, and it's probably not the best thing to be doing, but I'm gonna do it anyways because I'm lazy. I'm a bad programmer. Okay, so we allocate mem space for our file name, and then we go string copy this pointer to file name. Okay, so that will memorize our file name in here, and then when we call serialize, we use our memorized file name. So we just go file name. And when we go to this one, we have to do this. If file name, I'll make it the same as this one, whatever. We don't delete because we did it with malloc. See, I'm mixing and matching here because I want you guys just to know that if you create something with malloc, you have to get rid of it with free. So we go free file name. And then file name is equal to null. There. Now, one thing I just want to let you guys know is generally we should not be doing this. And I will not be doing it from now on. By this I mean using malloc, or just using malloc in general. We shouldn't use malloc because then it gives us more shit to remember. We have to remember that, oh, we created this with malloc, so we have to use free to deallocate it. And I almost used delete because I saw this delete and I was just going to be like, well, I'll just use this same code down here. Just change the name. But that would have been disastrous. So that is why we generally stick to new. It just makes things easier for us. There are very specific cases where you want to use malloc and free. And that is if you are using another function called realloc. But we're not going to get into that. We'll probably never get into that. So don't worry about it. Just use new from now on. Use new. And we will be using new from now on. And I'll show you how to create an array with using new. So far we've only created single objects with new. But I'll show you how to create new arrays in probably the next lesson or wherever, when it comes up. This is the last time you're going to see me using malloc, probably. So, that was a little detour, but basically we allocate space for our file name, and we deallocate it in the destructor. And now serialize should work. It's the same name as we were using hard coding, so it shouldn't change anything, but build. Failure. You fail. File and name. Sounds vaguely Germanic. Okay, so that seems to have worked. Yeah, sure. One final test. Let's try Bugger. 1 second. Okay, so I'm going to delete high score. Delete it. Yeah. And then I'm going to run this code, and that should save an empty scoreboard. I'm going to make sure it's empty. Yep, that's empty. And then I'm going to run it again. It should try to load an empty scoreboard. Let's see what happens. Okay, it worked. It didn't crash or anything. I wanted to make sure that it could load an empty scoreboard. And that's not what I wanted to click on, so fuck off, bro. Fucking... Alright, so I think most of the test cases that I at least want to try out are working now. Now what? Last thing I want to do is I just want to change the way that the scoreboard works, because the way I want it to work is I want serialize to be called in the destructor. So I'm just going to put serialize in here. Serialize. So I only want the scoreboard to be serialized or saved when we're destroying the scoreboard. And I only want it to be loaded when we create the scoreboard. So I don't want the user to have access to the serialize function. So what I'm going to do is I'm going to make this private. And now, because I made serialize private, if someone tries to call serialize here, we're going to get an error. Error. Serialize cannot access private member declared in scoreboard. So we're not allowed to do that. But we don't need to, because when we leave this code block, the scoreboard will be destroyed and it will automatically call serialize for us. Here. We serialize it, and then we recursively delete our scores, and then we free the memory for our file name. So serialize is private. We're not going to need test anymore because, well, that won't even work in our program. We don't have a console in our actual program. So we just need add score, and we need our constructor and our destructor. So the only two things that the user will actually be able to call directly are the constructor and add score. That's the only interface they have, and everything else is handled automatically. And isn't that beautiful? I think it's beautiful. It's making me kind of horny. I'm lying, by the way. Okay, so we don't need test there. Insert serialize. Serialize has got to be public because scoreboard has to access it. So this stuff all has to be public. Right? Yes. 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 All public. And the data is all private. Alright. So let's have a little test. Without test, because I just got rid of that. So we'll create the scoreboard, we'll add a bunch of scores, and if we are lucky, we should get a file at the end of the day. So no output on the console, obviously. Let's check a high score, and there's nothing here. Bollocks! God damn it. Okay, why is that not working? Ah, and I was so close. So close. We call serialize. And serializes opens the file for writing. Scoreboard. And opens the file for reading. If it exists. Reads some stuff and then closes the file. Okay, bro, why? Why is this not working? Now I'm pissed off. Because this should work. This should work, people. High score. Nothing. It's empty. Just when you thought that it was safe to introduce your code back into your main project, you find a little bug. Alright. So, scoreboard destructor. We'll put a breakpoint there. Okay, so let's check out our scoreboard first of all. First score is 4th. Next score is 2nd, 1st. Okay, so our linked list is fine. There's nothing wrong with that. Our file name is highscore.txt. Why is my breakpoint here? Fucking bullshit, man. Ah, that pisses me off. Yeah, that's weird. And I have this problem too. I put a breakpoint here, but when I run it, the breakpoint goes down here. And I have an idea of why that happens, but I'm not exactly sure, and it fucking pisses me off. It's a bug. It is a bug in the development environment. I'm gonna start debugging here. There we go. So we continue. Now if I step in here, will I? Yes, I get to my destructor. Okay, so that's good. Did that just fucking skip right over my serialize function? Why the hell did it do that? Okay, that is some fucked up shit, people. I am not exactly sure why that is happening. One sec. Alright, so according to this random piece of data I found on the internet, it's perfectly legal to call a member function from a destructor. However, you should avoid calling member function that accesses data members that have already been destroyed. However, this one does not access data members that have already been destroyed because the destruction comes after the serialize. Fuck, why did I put void in here? This is fucked up. Why did I put a void in front of this here? And why does this even work? I'm interested to know why this works. I guess this is creating a void data type called serialize and not initializing it with anything. This is creating a data... Ah, man. These are the kind of things that I do and that I don't see because I'm used to seeing void serialize. So I just think, yeah, it's a function. Fuck. Sneaky little ways that shit can get in there. Okay. Well, that was funny. It was funny that actually compiles, but whatevs. Alright, now it should work properly. It's a good thing I ran that last test though, because that would have fucked me over later on if I tried to move this into the actual game. I'd be thinking to myself that it was a problem with the interaction between the game and the scoreboard object, when actually it was just me writing some fucked up code, which is usually the case. Now, let's check to see whether or not our high score contains the data, and it does. And if we run this again, it should load the board and add a bunch more scores in and then save it. So we should get a bunch of duplicate scores. Let's run it again. And no problems in the console window. And if we open up high score, now we have duplicates of all the scores. Sorted properly, of course. Alright, so now I think we can finally declare that this object is created, this class. This is a class, by the way. I gotta stop using those words interchangeably now. This class is complete. At least as far as we need it. So I'm gonna copy it. Copy. And I'm gonna paste this mother trucker into, no, here, not here. Into here. Somewhere. Probably in game.h. I could create like a scoreboard.h file and stuff like that, but fuck it, I'm just gonna put it in here. Okay, I'm gonna get rid of this scoreboard, paste this one, and I'm gonna tab that over a little bit, get her all lined up. Holy shit, this one's pretty long. Is that it? Yeah, because I had a bunch of stuff, had a bunch of functions collapsed, so if it's completely expanded, it actually gets pretty long here, doesn't it? Well, relatively long. So there's our scoreboard class. We don't need our high score structure anymore. Let's go and delete that. Our poo structure can stay where it is. Now, clear scoreboard, insert score, save scoreboard, get score, load score. We don't need any of these. Good night. And now we have to actually go into game.cpp, and so here we go. Reset game, clear scoreboard, load score. So we're not going to do that. What we are going to do is we're going to go to game.h, and we're going to find out where our high scores are. We're going to delete those, and we're going to go scoreboard. Oh shit. That's fine. We'll create a scoreboard, just a normal scoreboard object. Let's call it board. That's fine. Now, scoreboard. Let's look at scoreboard here. It's only constructor. This is score. Let me just minimize this shit here. And we go to scoreboard. Bam, bam, bam. Delete that. There we go. So scoreboard only has a single constructor, and it takes a parameter. It needs a parameter. And if you have an object that is embedded in a class, like we embed scoreboard into our game class, it's embedded in there. And if we do that, we have to initialize it. We have to give it its initializer value up in here, because it gets created at the same time as we create our game object, or we create an object from our game class. And so it needs its parameters really quick, and that's why we have to put it in this initializer list. So we go board, B-O-A-R-D, and fuck. I'm going to go into game.cpp. I'm going to go here, and I'm going to go # define board name highscore.txt. There. And I'll call board name. And that will create our board with the parameter, the file name parameter that we defined in our # define macro, which is highscore.txt. So we have to initialize our board. We have to give it its initializer value in this list here. Same with graphics, keyboard, audio, mouse. They're all embedded objects that are embedded in our game class. So we don't need load score or clear scoreboard anymore, because that's all handled in here, in the board. Now when we destroy our game, our scoreboard will automatically be destroyed, and it'll automatically be saved. So we don't need this anymore. We don't need anything in our destructor. We don't even need a destructor anymore. But I'll leave it just for fun. Now, what else? Clear scoreboard, we don't need that. That's useless. Insert score. Now we don't need this either, but no, we don't need this one. But we do need to know where this is called. So go to find all references. Insert score, game, insert score. Here, here, and here. So that's just at the game over thing, right? So instead of doing insert score, what we're going to do get score. Yeah, we're not going to have a get score function either. We're going to do board dot add score. Now I need to look at get score because I want to find out. This is cramping my style. I need more space. Reset goal. Okay, so insert score, that's useless now. Get rid of that. Save scoreboard is useless, but get score, we go high score. No, that's not useful. Score is equal to end goal, so we'll just use end goal. Where is it? Here. That's our score. And here we have to get this time t current time buff length. Score.time. Right. Okay, we have to have a thing that gets the time. Ah, right. I wanted to put this inside the... now I remember what I was going to do. I wanted to put this time shit inside of our scoreboard function. That way we don't have to look at its ugly ass time stuff in our game function. So what I'm going to do... What I am going to do, friends and comrades, is... we'll copy this stuff. That's right. I should have done this when I still had my test bench, but whatever, we'll do it in here. It'll probably work. Maybe. And we do it when we're creating a new score. Okay, so now the constructor for score will only take the actual score. It won't take the time. And we're going to create a buffer here. So first we said this point of the score is equal to score. Now I don't need this anymore because we don't have the time parameter, so I don't have to use this pointer to time. You'll see what I'm doing in a second. Car buffer. Again, we'll assume 128 for the length of our buffer here. And then we're going to do this. Time buff len. We have this thing here. So let's use that here. Fucker. We use time buffer length here. And what else? Where else? There was one more place where I was going to use it. Probably here. And maybe in here somewhere? No. Okay. I think just those two places was where I had it. Yeah. So we'll use time buffer length in these places. And so we set this score equal to the score parameter. We create a buffer. We get the time. Then we convert the time into string form and copy it into the buffer. Then we allocate memory for a string, which is the size of the buffer, the size of the string in the buffer. And then we copy the string in the buffer to our block that's pointed to by time. Yes. So we'll have all the time shit inside the constructor for score. And that way we don't have to look at all this ugly ass shit chilling out in the middle of our game class. Is that sexy or is that sexy? I believe that is rather sexy. So now we don't need this shit. Get rid of get score. get rid of load score. And that is the end of the score functions. So here for add score, we just pass it the number of goals for the score, and it takes care of the time stuff all inside that class. You see how everything is so nice and contained now? All those function calls and shit, they all just resolve to a constructor and a single call down here. And that's everything else is automatic. The saving is all automatic in the destructor, and the destructing is all automatic because the object is embedded in the game class. It's so fucking beautiful, it just makes you want to shit rainbows. Alright, where's my problems? I got problems. I got lots of problems, but it's okay. We'll get this shit. Term does not evaluate to a function taking one argument. Term? I think I probably have to include time.h in here. That saved, that killed a bunch of problems. But it did not kill this problem. Term does not evaluate to a function taking one arguments. Now we have problems. Now we have big problems. You see, the function time is now getting mixed up with game.scoreboard.score.time. So this time and the time function are interfering with each other. And that is a big problem. Now I think if I do this, it'll work. I'm thinking this will work. No. I think that did work because look, we didn't get that error anymore. No overloaded function takes two arguments. Here we go. So add score only takes one argument, and this only takes one argument now. And this one only takes one argument. Let's try it again. And we succeeded. Okay, so the problem was that, like I said, this time was interfering with the global function definition of time. And the way I solved it was if you put these two, the scope resolution operator in front of an identifier, it specifies that I want the global definition. So I don't want the local definition here. I want the global one. And that worked. Phew, I was afraid I might have to rename this and rename it everywhere, and that would have been, well, I could use, find and replace, but still. It would have been a pain in the ass. So our build succeeded. Now the question is, will our game actually run properly? And will it give us the results that we desire? We'll go to pooface ex plus alpha. We'll delete high score. Delete that. And we'll cross our fingers. It could fuck up. I could have made a mistake, especially in here. But we're going to give it a shot. Okay, so far so good, right? Whoa, run away. There we go. I want to die now. Good. I wasn't sure if I created a button to reset the game, but I did. And that was well done. Well done by me. Okay, where's my shit? I'll just die. Get another one. We'll die with 0. We'll get a bunch now. 3, 4. Oh, well, I wasn't planning on dying that time, but whatever. Let's get a bunch now. 1. Where is it? 2. Whoa! Fuck off. Where's my yellow? 3. 4. 5. Whoa! Get away. 6. 7. Ah, shit. Okay, that's enough. So now we'll delete that. And let's look at a high score. So our top score is 7, then 4, 4, 2, and 0, which I believe is basically correct. And you see the last score that I attained was the 7, which is correct. So, it looks like the scoreboard is working out fantabulously. Now I just want to try loading it again. I want to try loading a game here and adding a single score to it. And then deleting that and checking it out. And now I got a 1 in here. So, loading, saving, adding scores, everything works perfectly, and it is now super neat, clean, and sexy. And that, my friends, is that's one example of how to use classes to solve a problem. And it's also been an example of linked lists, and also how to use the new operator. I'm sure it's been an example of other shit too, but I can't think of that shit right now, so yeah. It's been good. It's been good times. So I'm going to record probably a little preamble about just a little introduction before the introduction, because there's a couple things I want to say that I didn't say there. But yeah, basically, just to reiterate what I'm going to be saying in the beginning. If you found this too difficult to follow, if it was just too much and your brain basically exploded, I'm gonna have a poll on the web, on the boards, on the message boards, and you can tell me in that poll if you want me to make another lesson which takes it a little easier, a little more, I don't know, gentle with the beginner. And if you do that, then I will probably record another easier or simpler introduction to classes, and I'll make that the beginning of the intermediate series. And this lesson will then become just a I don't know, an additional something, a appendix or something like that. Yeah. So anyways, this is classes. This has been classes. And next lesson we're going to be learning about binary numbers and shit like that, which is going to be important for when I show you guys how the framework actually works. You're going to need to know how to manipulate binary numbers for that. And in order to teach you binary numbers, we're going to do alpha blending, because that is a good introduction to binary numbers and bitwise operators. So, next lesson, alpha blending / binary shit. And that's all. Toodaloo.